All right, guys. So based off what you've told me, it looks like I need to hit three things. I need to talk about these inequalities, which are actually piecewise functions and how to find the limits of those, as well as conjugates, and then some rational expressions, find the limits of those. So let's start off with this one. Here we have f of x written in the green. It's the piecewise function of 1 over 2x when x is less than or equal to negative 2, or 2 to the x when negative 2 is less than x, which is less than or equal to 0, which is just which is just this part right here. Because these parts just tell me what part of the equation you're going to use based off of the x values. That's why these are written in terms of x right there. Okay? So since we're trying to find the limit as x approaches a negative 2, we see right here that negative 2 is sort of that trade-off point where it's going to switch from acting like the top equation and then to start acting like the bottom equation. So that means we need to figure out the left-hand limits right now. All right. So we need to make sure we can determine that the left-hand limit, so the limit as x approaches negative 2 from the left side of f of x, right? So because we know it's coming in from the left side, we're going to use this one right here. And hopefully my color coding makes sense. So it's really the limit as x approaches negative 2 from the left of 1 over a 2x. So we're going to try and do the direct substitution and hope that it works out. So if I do that, I have 1 over 2 times a negative 2, which would be 1 over a negative 4. So I get a negative 1/4 as the value of that limit from the left side, right here, which I'm circling. So if that's what's happening on the left side, we need to talk about what's happening on the right side as well. So same setup. Oops. All right. Now we're going to look for the limit as x approaches negative 2 from the right side of f of x, which means that we're finding the limit as x approaches negative 2 from the right. And because we're coming in from the right, that means we're going to look at this other side, because if we look at this inequality, this part right there, negative 2 is going to be less than those numbers that would fall, that we could use for x. So because negative 2 is less than those numbers are greater than the negative 2. So that's why I know that represents coming in from the right side. So we're going to have 2 to the x, which will be 2 to the negative second, which should be 1 over 2 to the second, right? Because rules of exponents, when it's a negative, you take the reciprocal of the base. And since the base is 2, that's why I have a 1 over 2. So now this comes out to a 1/4. And if you didn't follow that, just know that from this step, you can just use your calculator and you should see that you get a positive 1/4. So now if you look at the two answers we have, the one in the blue and the one in the red, aka the left side and the right side, if this limit that we were asked to find in the green does exist, it would have to mean that the left side and the right side are exactly the same, but they're not, because one's positive 1/4 and one is negative 1/4. So as a result, we say does not exist for this example. Okay? So I'm going to go ahead and pause and set up for the next problem, which should be the conjugates. Okay. So we're back at it, and if you notice, we have the limit as x approaches negative 1 of the x plus 1 quantity divided by the square root of an x plus 5, which you subtract 2 from. So as always, you should try to just do a direct substitution. So if we do that, we should have -1 plus 1 over radical -1 plus 5 minus 2. Because if I can just get a number from here, I save myself a bunch of work. But I know up top I'm going to get a 0. Then I have square root of 4 minus 2, which will also get me 0. So I get 0 over 0, which is that indeterminate form. Means we got some work to do. All right. So in this instance, we have to work with that radical, that conjugate form right now, because this is the part where I'm going to guess I can manipulate this. So I make it so I don't end up with that 0 at the bottom, and hopefully something cancels out. Because when you get 0 over 0, something probably canceled out, and let's see if we can prevent it or simplify it so that we don't have to worry about that indeterminate form anymore. So now I'm going to take a look at this, and the goal is to manipulate this and I'm going to multiply by the conjugate. So in this instance, because I have a radical minus a number, I'm going to do that same radical plus that same number right now. And I'm going to go ahead and try to multiply. So when you multiply up top, typically I'm not going to distribute because I'm guessing that if I need to cancel something, I need to leave it in a factored form here. And so this is the factored form I'm going to leave it in. And then I'm going to see what happens with the denominator. And if I need to multiply, then go ahead and multiply the top out. But if I simplify the denominator and I see something cancel, well, my job got a lot easier. And so what I was saying in class is this. This is a difference of squares pattern in that right now it's this quantity multiplying, let's go with orange, this other quantity, and the only difference is that one has a plus and one has a minus. So imagine that you had, let's say, an x. Let's make it purple so we color code. Right. We have an x in one parentheses, and let's say we had some other number. Let's just call it another variable. Let's call it a. One's a minus, one's a plus. So at this point, if I was going to multiply this out, right, the x multiplies the x, so we get that x squared. And the x would multiply an a positive a, so we get a plus ax. Then we have the negative a multiplying the x, so it'd be a minus ax. Then we have a negative a multiplying a positive a, so we get minus a squared. And the reason why I'm doing this is to show you the pattern that's unfolding so I can take a shortcut and you can make sense of why that shortcut works. Right here, this is where the cancellation occurs. The ax and the negative ax terms just disappear. So all we're really left with is the first term that is squared. So that first term is the x squared in this instance, minus the second term. And the second term is going to be that a squared. So if you understood how I did that, now we're going to do the exact same thing with the original problem. So that means that the first thing I underlined, the purple parts, means I have a square root of an x plus 5. That's eventually going to get squared minus the 2 squared. All right, so take a moment, make sure you really understand the strategy and pattern that I'm taking advantage of to make my life a lot easier. Because if you don't do what I do, like, you can still multiply it out in FOIL. That's fine. It's just more work, and it's like 4:30 on an afternoon, so I'm trying to go home. All right. So when we do that, we end up with, in the numerator, still the x plus 1, because I refuse to distribute right now, times the radical x plus 5 plus 2 over, and in the bottom, when we kind of distribute, or when we FOIL this purple term, or sorry, not FOIL, when we square this radical x plus 5, the square root and the radical cancel out. So you just have an x plus 5 left. And we're going to subtract 4. So in reality, down here, this turns into an x plus 1. So once you have that right there, you can see the cancellation. So let's just go ahead and knock it out. X plus 1's cancel. So this expression simplifies down to just this term that I'm about to highlight. Okay. Boom. This is all that's left over. So when they're asking me to find the limit, I'm really just supposed to find the limit of that term right there. Come on. So it's the limit as x approaches negative 1 of radical x plus 5 plus 2. And when you plug that in, you end up with the square root, there we go, of negative 1 plus 5 plus 2, which is just the square root of 4 plus 2. Final answer will be 4. And that's it. And that's how I would handle these conjugates. And notice, I chose this one because you have the conjugate in the denominator, or the radical in the denominator. It didn't matter. The solving strategy is still the same. So don't get phased by that, as long as you made sense of how I did the purple and orange parts. That's kind of where the integrated 4 skills kick in. Right? So let me go ahead and pause and set up for the last one, which will be with rationals. All right. So last but not least, we have this expression. We have the limit as x approaches 0 of the quantity 1 divided by an x plus 8 minus a 1/8. All of that gets divided by x. So as always, you should just see if you can just plug in the 0 and hope that everything works out. Life is great. 0 plus 8 is just 8. So it's 1/8 minus 1/8 over 0, 0 over 0. But we kind of knew this, because why would Mr. Rodriguez choose a problem that didn't apply right now? But you should always just try that first as a gut instinct. And then all the other techniques I'm showing you are kind of your fail-safes. All right? So because we get that indeterminate form again, that means that we can manipulate the blue equation, rewrite in an equivalent form, and get something to cancel out so we can continue on our journey. All right. So I'm going to focus on this part right here, because when I have two fractions being subtracted, I kind of want them to have the same denominator, so I can just simplify it as I go through this. In this instance, we have the x plus 8, and we just have 8. Now, as tempting as it is to just add x to both sides, you can't just add the same quantity to a fraction and say it's the same thing, right? I gave an example where yesterday I say we had 1/2, right? If I add 1 to the top and add 1 to the bottom, kind of representing what happens if I add an x top and bottom, same thing, we end up with 2/3. Now, if mathematically that was possible, that would mean that the 1/2, I did the same thing top and bottom, these two should be the same. And you know they're definitely not the same. So that's why we can't just add the x. It doesn't work out that way. So what we have to do instead is we just have to multiply these by each other. Multiply this by an 8 first, top and bottom. Multiply by an x plus 8, top and bottom. Right? And it's these integrated 3 skills at this point, because I know that this is in the rational functions unit when you guys talk about graphing and you have all those horizontal asymptotes and whatnot, you talk about things like this. Right? And if you multiply a fraction by the same number top or bottom, right? So kind of revisiting why that would make sense. So let's say I just chose a different number to multiply by. Let's say I multiplied the top by, I don't know, what's a good number? 5. So I multiplied the top by 5, multiplied the bottom by 5. This time we would end up with, 5/10. Which then they have a common factor of the 5, so we know it reduces down to 1/2. These two are the same, so that's why you can multiply a fraction by the same quantity, top or bottom, and have it be equivalent, because you get that kind of cancellation here if you wanted to. Yeah. All right, because I could just leave it like that. 1 times 5 is still 5. 2 times 5 is still 10. But if you cancel it from top and bottom, common factors, then they kind of go away. So going back to this problem, this now becomes 8/8 times an x plus 8 minus x plus 8/8 times an x plus 8. All right. And now since we're subtracting, we're going to take the top minus the other numerator. All of that has the same denominator, so we just kind of combine into one fraction. So we get 8 minus x minus 8 over x times an x plus 8. So we end up with a negative x over 8 times an x plus 8. Okay? So all this work was just to figure out what the numerator of the original problem was. So now let's go back to the original problem. All right. Write it out again. It was the limit as x approaches 0 of 1 over x plus 8 minus 1/8 over x. Right? And we figured out that this we can rewrite and becomes what we just found. It becomes a negative x over 8 times an x plus 8. It's still being divided by that original x there. So hopefully my color coding makes sense, even though I kind of shifted things. So this is what we're trying to find the limit of. And to further simplify this, if you think about this as an x over 1, you're dividing two fractions. And when you divide two fractions, you keep the first one as is, and you multiply by the reciprocal of the second fraction, so 1 over x. And because we remember kind of how the multiplication works, we can just go ahead and cancel this x and that x. So we end up with a negative 1 over 8 times an x plus 8. So we're really finding the limit as x approaches 0 of 1 over 8 x plus 8. So now all you have to do is just try the direct substitution again. X plus 8. So this becomes 1 over 8, 0 plus 8. So it becomes 1 over 8 times 8, 1 over 64, and that's our final answer right there. Boom. So hopefully this has answered some of your questions and I showed my work sufficiently so you can make sense of it. If not, send me a message. I will not answer messages back tomorrow because Saturdays I just need to decompress, guys, to be completely honest. And but I will get back to you guys on Sunday. So hope this helps. Have a good weekend. I'll post the answers to the other review guide probably on Sunday at this point because the day got away from me and I apologize. But hopefully you guys are working on it and Sunday you can just check your answers.